Hello, everybody. So we are a new episode. We are talking about Mysteries World of Wolves. So the different bird group and really interesting bird group. And Peter and I will have very special guest. I mean, he's really special for us. So I'm not gonna tell right now, but I'm gonna take Peter to the studio. Here is the Peter. Hello, my lord. How are you
It's
doing?
the Peter. Hi, Utku. How are
Long
you?
time I see you. I mean, yeah, since long time passed,
Yeah,
and we
but
got the last episode. We reached more than 1,000 people watched, so it
people
was
like
nice.
Kiwis. Yeah,
Yeah, and then hopefully people like today's episode. We are gonna talk about what?
owls.
Owls. Yes.
Owls. Yes, people
So
like owls.
yeah, of course. I mean, very charismatic bird group. So we have special guest today. Should
We
we
do.
mention right now or should we just wait?
Well, I think we'll wait to the end to bring our guest on and tell people why he's here and show them
Surprise.
some interesting things. Yep.
Okay. So I'm gonna take our presentation here. Owls.
Wow. Yeah, look
So
at that.
in total, a lot of species, 216 species worldwide, and then two different family. One family looks like more and more species than others. I don't know
Hmm.
why. I mean, why? Do you have any answer?
Well, it's a single order, the Strigiformes, with these two families.
Right.
Um, I'm not exactly sure why one family would have fewer species than the other, but that's just the way it worked out. Some something going on with the evolution of the group.
Yeah, the other one are probably diversified very broad. So okay, so this is the numbers and it's interesting. And
There's a neat picture there. That's a great gray owl with a
right,
chipmunk. Yeah,
so this is the all distribution in the world except Greenland. They are everywhere.
and Antarctica.
Yeah, oh yes, sorry.
Yeah,
Yeah,
no birds, none there. And this is the distribution of both families in the order. So that's
right.
the total 200 some species. Yeah, pretty much found everywhere.
I mean everywhere in the world. So it's
It's-
definitely
it's-
interesting, but there are some endemic species also, as far as I
and
know.
and you're going to see the variation is pretty incredible in the group.
Right.
Um, you got them
So
distributed all around the world like this.
so the last minute we added this slide. You sent me the picture.
Yeah.
So I have no idea what's happening here, and you
Well,
can explain probably.
right. I had almost forgotten about this. I had seen it, I don't know, a couple of years ago, and then when we were putting together the owl podcast, I remembered that some people were doing work with ultraviolet light and owls. Now, a lot of birds can see in the ultraviolet. So colors that we can't see on the birds kind of glow on the bird, and members of the same species can see that. And
Mhm.
some birds are iridescent, like common grackles and things like that. But owls, are generally sort of brown or gray or reddish, and you don't expect them to have this ultraviolet glow to the feathers. So this is a saw-whet owl. It's one of the small northern owls. And apparently, if you shine an ultraviolet light or a woods lamp on the feathers, this will glow like this. And presumably, other owls can see this. But when there's no ultraviolet light on it, you can't see it. We can't see it. And
Yeah.
so I took a quick look at this again, and apparently, bird banders, people who put identifying markings on these owls for research, bands on their legs and so on, they say that the color, the extent of the color, and the richness of the color is an indication of age on these birds. So there apparently is a difference in the ultraviolet color between adults and immatures, and and juveniles and that sort of thing. So I found that really interesting. So that's what this picture is. You can find these photos on the web of different kinds of owls, not just the saw-whet owl, but a whole bunch of different ones.
Okay. Okay.
Hmm.
So
It's a small one.
tiny owl here, and
Yeah,
yeah, the
yeah. This
size matter, I think, in the owls. So that there
it
are some
matters. Yeah.
size always matters in birds, but
So this is a pygmy owl of some sort. I don't know what all the species are, but you know you can tell it's an owl, but it fits in somebody's hand. It's a tiny little thing. And owls, of course, are birds of prey. They have raptorial feet and hooked beaks. You know, they're not vegetarians. They eat other animals. So
they
a little
just
tiny.
active in the night.
Hmm?
They just active in the night, not the daytime. Only one species, as far as I know, that active in the daylight. This is the um what's the name? I mean, Turkish name is kukumau,
Mm-hmm.
little owl.
Yeah, yeah. Well, that's not entirely correct, Dutku. Some owls are completely nocturnal. Some are diurnal, and a lot of them are crepuscular. They're active at dawn
Hmm.
and dusk. Um, and this is one of these small pygmy owls. So this bird is looking for insects for the most part. You know, it's eating grasshoppers and crickets and things like that. Probably will take some small lizards, maybe a small bird. Um, but it's interesting that these owls of various sizes take different size prey. So they can occupy the same range, but they're not competing with each other for food because they're feeding on different size prey.
Okay, okay,
Mhm. Now we go from small to really large. This is the largest, one of the largest owls in the world. This is in the genus Catupa. This is one of the fishing owls.
right,
You
right.
might have heard of those.
We,
This
we have
bird is
in
huge. Say again?
we have in Turkey one species in Turkey breeds.
Yeah, and they're found in Russia, places like that where it's cold, um, and I think they specialize on catching fish. Actually,
The Latin name is Ketuba ziolensis.
yeah, yeah. I think there's a couple species in the genus,
Yeah,
but look at the size of that bird.
I mean it's
Um,
yeah.
Tremendous.
So
Yeah, it's no longer a matter of when I kill,
I
but
kill
rather,
next. Yeah,
but rather who. You know, you get it? Who? It's an
yeah,
owl.
of course. Yeah.
You know, so I guess we're talking a little bit about the diversity of prey items in owls. So before we take the next slide, though, let's look at this owl. No, go back.
Oh, go back. Okay,
Yeah, yeah.
sorry.
No, back to that one. Nope, nope, no, the other way. The other way.
Oh, the other way.
Yeah, yeah. Right there. No, no, right there. Stop. So here we have, I just wanted to show kind of what a basic owl looks like. You know, they've got the eyes that are very much in the front of the head. They've got this forward facing vision, binocular vision. They've got rather long legs, and you can see the talons at the ends of the toes. And
Hmm.
owls have a zygodactyl position of the toes, meaning there's two toes in front and two in the back, and they can kind of swivel around a little bit. Owl plumage is very soft. Um, The flight feathers of owls, the long primary feathers, have these little ridges on the leading edge of the feather so that when the owl is flying around looking for prey, the prey doesn't hear them coming. Their wings don't make any sound. It's like a big moth. And also,
Right.
owls use their hearing to find prey. Some do it more than others. They have very, very good hearing and a strange arrangement of the ears in some species. So they don't want to have a big flappy wing that's making all kinds of noise. It would impede their ability to hear their prey on the grass or in the leaves. And so they've got all these really cool adaptations. So all owls have that sort of thing, but then you've got all this diversity within that owl template. So we
Okay.
can
May
look
I?
now at the prey. Yeah.
Yeah. So the owls have fascinating the diet that includes mammals, birds, or even amphibians.
Hmm.
So how does this, I mean, difference, variety influence their role in the ecosystem? So can you say something?
Yeah. Well, here we have a horned owl with a snowshoe hare and that great gray owl with a chipmunk. You can see that they're both big owls, but they're eating mammalian prey of different sizes. Um, the horned owl is, pretty nocturnal. The great gray owl might be seen in at dawn and dusk more. So even if they occupy the same area, they're feeding on slightly different sized mammalian prey, or as we have it written there,
And
mammalian prey.
also, Peter, they are nocturnal, and they're, I think, good for the population size of the other small mammals that are
Yeah,
active in night. So
yeah,
yeah, I mean, they
yeah. A
just
lot
try
of,
to stabilize the population size of the other mammals.
yeah, a lot of their prey is active at night, although chipmunks are see them out during the
Right.
daytime often. So yeah.
Yeah. Okay, so I'm gonna.
Okay, so we have a
They
little.
also hunt avian species.
Sure, they eat other birds. Yeah.
Right.
So that one on the, hang on, go back.
Oh,
Yeah.
sorry.
So that one on the left, which looks like maybe I don't know what kind of owl that is, a flammulated owl or something like that. Looks like it's got a little siskin. And then the
Yeah,
one on the right is eating a frog.
it's a
And you
small
can
frog. That's true.
yeah, and you can see the talons on that owl on the right. Look at how powerful those talons are. So
Of
they
course.
grab
Yeah.
onto something that's they're not going to let it go. And most owls will grab their small prey. They'll grab small prey by the head and kind of swallow it whole head first. But some of the larger owls will tear it apart, particularly if it's a larger prey item.
Okay. So may I go
Sure.
further?
Yeah.
So this is diversity based on the phylogeny. So
Mm-hmm.
this study, the George and Jeff,
Mm-hmm. And Lisa Mertz in the
famous
Department of
famous
Ornithology.
phylogeny, remember in the department, still I think hanging on the wall.
Yep. So
So
there's
they
some interesting things there. Yeah, they looked at the at some of the genetics of the owls, and they made some interesting observations. If you look all the way down at the bottom, you can see that on the bottom left, you can see that group there called the eagle owls, right?
yeah
And you can see a great horned owl in there, and you can see a snowy owl in there. And for a long time, people thought that the snowy owls, these Arctic owls, were in a different genus than the great horned owls. It turns out the genetics show that snowy owls are just really big great horned owls that have turned white and have lost the ear tufts, the feather tufts on the head. And so the snowy owl is now in the genus Bubo, along with the great horned owl. So that's one of the neat things that was found out. And then you see this strange bird called Xenoglox off to the right that has kind of been uh, figured out where it is in the phylogeny. And then there's some other strange things in the family Titanidae, the genus Photalus. People didn't really know where that was where it fit in very well. We know now that it's in with the barn owls. We can talk about that a little more later.
okay, fine. So let's move to the Titanidae, the another family.
Yeah, well, let's look at the two families. So if we go back, let's go back to that slide, please. That's that last one. So it says family Titanidae there, but those are not Titanids pictured.
No, no,
Those are
no,
in,
no,
yeah,
no. I
yeah,
just put
yeah,
these pictures. It's not
yeah,
that
yeah.
definitely. So
Just
it's
just wanted just
important
wanted
for the
people to know.
audience. So I know. Yeah.
Hmm. So yeah, the family Titanidae. These are the barn owls, the grass owls. Sometimes they're called, and people are probably familiar with the barn owl. That's the most famous one, the most ubiquitous one. That's the one in the upper right, Tyto alba.
Mm-hmm.
It's very widespread, but look at all the variation in that family. All these kind of cool barn owls or grass owls and things like that. So this is just a nice poster showing the diversity in the genus Tyto.
Okay. Yeah, that's true. And I have, well, I'm gonna have another question, but not not really especially for this family, so I'm gonna take this one later. So
Mhm.
this is the Titoniida distribution.
Yeah. Yeah. So you see, it overlaps completely with the other family,
Right,
the
right,
Strigidae. Yep.
right.
But very widespread family.
I mean, very widespread. Yeah,
Hmm. Now there's a that's the quintessential barn owl, Tyto owl, but this is the one that you would see in
very nice
you know,
picture.
yeah, it's a beautiful picture. They used to sometimes call them heart-faced owl because the facial disc that they have there is shaped like a heart. Um, Most of them have dark eyes as opposed to yellow or orange eyes. Um, they don't really have any feather tufts on the top of the head. Um, you can see that the legs are long and the toes are long with the talons on the end, and they also have silent flight. You can see that primary feather on the wing. You can almost see those ridges along the edge of it. The air goes right through that, and so there's no hard edge to the feather making any sound.
So
And
in owls, you said the silent wing. I mean, silent flight. So they
silent
are
flight,
lucky
yeah.
of all these hooks in the primaries.
Um, yeah, well, they have the hooks that keep the vein of the feather together, but you can almost see along the leading edge of that big feather at the bottom, the primary feather, the
Mm,
edge. You can see those little ridges on it.
yeah,
So think of a pigeon. A pigeon has a feather like that, but it's very stiff without those little ridges. So when a pigeon takes off, it
right,
makes a lot of noise, right? Flap, 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 flap. But with
right,
the
right.
owls, they don't make any sound at all. And the barn owl is famous for finding its prey using its hearing. They have those asymmetrical ear openings. You can't see the openings because they're covered by feathers, but one ear is lower than the other, so that they kind of triangulate the sound of a mouse in the grass or in the
Oh yeah, it's
leaves. Yeah,
important. I know, I know.
yeah. And then the face there, those feathers, the facial disc acts as like a parabolic microphone,
Mm.
so that the sounds that the mouse is making or the prey is making, or if the mouse is squeaking even, those sound waves travel up towards that owl's face, and the facial disc directs the sounds to those asymmetrical ears. And the owl can find the prey with no light. They do experiments with barn owls. You put them in a room with zero lights, pitch black, and you have some animal, a mouse, run on the floor. And they catch it 100% of the time without any light. Of course, they can see. Owls don't have cone cells in their eyes, so they don't depend on color vision. Their their cells in their eyes are mostly rod cells, which are useful in low level light.
Okay. So I was gonna ask you. I mean,
Hmm. I
you
covered it.
already
Yeah,
mentioned.
yeah.
Yeah,
But they're
definitely.
beautiful
Okay,
owls.
thank
The Titanidae are
you. Yeah,
gorgeous.
right.
And then
I
there's
was
a
gonna
lot of
ask.
variation. Yeah.
Yeah,
Hmm.
I'm gonna pass.
Yeah. So here's another title. Look at this thing. I
I mean,
believe
this is
this is.
yeah,
It's cool, right?
yeah, definitely.
It's like a black barn owl, And I don't know what the common name is, but I believe these are found in New Guinea.
Yeah, definitely. I mean, look at the. I mean,
Isn't that cool?
face and color. It's
Yeah.
definitely different, and size is different.
It's definitely a Taito.
Right.
All
Look
right,
at
now
the tiny.
this is in the genus Photilus. This owl is found in parts of India, parts of Asia. Not exactly sure what the distribution is. Um, but for many, many years, nobody knew what the taxonomic position of this owl was. See, it's got
Right.
dark eyes. It looks a little bit like a barn owl, maybe, but it's got a little bit of feather tufts on the head, right?
Mhm.
Which, is often found on the other family, Strigidae. But in that phylogeny that was done at the American Museum, we now know that this genus Photilus, not Tyto, is in the Titanidae.
Okay.
Hmm.
The same
So the
picture.
next,
You
yeah,
remember? I
same
mean,
same picture, yeah,
picture.
yeah,
So it's just for the owls.
yeah,
Owls.
yeah. These are
Regular
burrowing
and
owls. Yeah,
yeah.
yeah. So it's the next family, Strigidae, contains most of the owl species.
Right.
And here's a very famous owl, the snowy owl,
Snowy owl
which
from
is,
north.
yeah, circumpolar in distribution.
Right.
Here it is, coming down on a vole, some kind of a rodent. And this is a big female. Females have a lot more mottling and brown color. The male snowy owls are almost completely white. And it's similar in the owls, like it is in some of the hawks. There's a reverse sexual dimorphism where the females are larger than the males.
Right. Right.
Right. And in this case, there's a little bit of a color difference. This is the eagle owl, the Eurasian eagle owl.
Yeah.
Bubo, right.
Yeah.
Forward facing, yellowish eyes. Really looks like a cat. And it's got these feather tufts on the head. Now, it's important to remember, and most people know, those aren't the ears of the owl. Those are just feathers on the top of the head.
Feathers. Yeah.
And there's been some speculation as to why owls might have evolved that kind of a cat-like face. And I learned in early ornithology classes, I don't know how valid it is these days or what people think, but if you come up to an owl on the ground, or if it's on prey and it's on the ground, they puff themselves up. They puff their feathers up. They look twice this size, 3 times this size. And they face you. They look at you. And it's thought that sometimes if they're approached by a coyote or another predator or something like that, they look more feline. They look more like some kind of a bobcat than a bird. At least that's what I was taught. So that's more intimidating to a mammalian intruder. I don't know if that's valid or not. It makes sense, but looks more like a big cat, like a bobcat, especially when it's puffed up and kind of being aggressive. So that might be some way of defending themselves. And additionally, they have feathers that are streaked and mottled, so they can blend in too. They can look like a piece of bark. They can look like the background. So they've got really good camouflage plumage.
Okay. Well, it's interesting information. I didn't know that.
But you also notice that the Strigidae, including these smaller ones here that we're looking at, they don't have as prominent a facial disc as the barn owls. It's there, and they're probably using it to direct sound waves towards their ears, but not as much as the barn owl. The barn owls, the Titanidae, they're champions of using their hearing to find prey.
So
they've
that
got a couple
one,
of yeah, I'm not sure of what some of these species. It looks like a screech owl, but I don't think it's an eastern screech owl. It's got a strange.
Strigidae, yeah.
Yeah, and then all this variation.
Right.
The tropical. So a lot of these tropical owls. You can see this is a long-eared owl.
This is common also in Turkey.
Mm-hmm.
That one.
This is the barred
So
owl,
this
which
one-
is mm-hmm.
Yeah. Yeah.
dark eyes. This is the great gray owl with light eyes.
Picture. And
That's a
that
hawk
one-
owl. Yeah, the
that one,
genus.
it's not like a owl.
The genus Cernia or Cernia. It's not a hybrid hawk and owl. It's an owl, but it hunts during the day. It's diurnal, and it kind of looks a little bit like a hawk. When it sits, it's kind of upright like a hawk. This is the burrowing owl. Mm-hmm.
Right.
They live underground. They lay eggs underground.
It's a tiny one.
This is the little saw-whet owl that we have up north. Yeah, it's about as big as a parakeet. So here's the great horned owl, Bubo virginianus. This is the quintessential owl. When you think of an owl, this is the bird people kind of think of. Big, got the feather tufts on the head, big powerful feet, forward-facing yellow eyes, the facial disc. They're also called hoot owls, or tigers of the woods, things like that. They have a wide distribution. We're gonna talk quite a bit about these. So go to the next slide. You can see the global range of.
The range is very wide.
It's all New World, but it's it's everywhere. Just it's not in the Amazon.
I mean, especially in North America, it's everywhere.
Mm-hmm. Widely distributed, and there's a bunch of subspecies. Some are darker, some are lighter. Interestingly, the ones that are up north in the Northwest, they tend towards lighter plumage.
Mm-hmm.
And as we said before, you've got the snowy owls, which are above that, which
Mm-hmm.
are really just these white great horned owls that have become white and have lost the feather tufts on the head. And I don't know how many subspecies, quite a few subspecies of the great horned owl, if you're interested in subspecies or if you think they're valuable to some extent. There's even that little isolated population in Central America and on the East Coast there, you see it. Here's a great illustration of the sexual dimorphism. That's the female on the left and the male on the right. She's much bigger than he is. Great horned owls, at least in New York State, where I am in the north,
It's
they
a nice
start to,
pair.
yeah, they're an old married pair, you can tell. And here in the north, horned owls, they start nesting early. They lay eggs in January.
Okay.
And these owls don't build their own nest. Great horned owls will use an old crow nest or an old hawk nest, or they'll nest on a cliff. Very variable nesting sites. There's a neat old photograph in the ornithological literature of a bald eagle's nest, big bald eagle's nest, and the eagle is in the nest. And there's a great horned owl sitting right next to the eagle in the nest, laying its eggs in the eagle nest with the eagle in there. So, here's some information, some illustrations about their breeding biology. So the upper right shows the owl eggs, the horned owl eggs, but most owl species have round white eggs. They nest, often inside the cavity of a tree. So the eggs can be round. They can roll around. They're not going to fall off of out of a nest. They're not really camouflaged. They're just white like that. And on the left, you see a great horned owl with two owlets. They're young. They're inside a cavity. And on the lower right, you got a couple of owlets that are older. They look like they're in an old hawk nest or something like that. And they'll probably fledge. Those birds would fledge in a couple more weeks. They're almost ready to leave the nest. So they have this down at first when they hatch, and then the feathers push through the down, and then they wind up leaving the nest and hopping around in the branches and still get fed by the parents, and then they start to learn how to hunt. And here they are getting older. So this is a little sequence of the young great horned owls growing up, losing their fuzz, and
Right.
getting ready to leave.
It's nice. Yeah, it's nice illustration. Yeah, definitely.
Yeah. The lower left of that picture was of the adult and three young. See,
Right.
that's the adult on the right, and they're in a cactus. This is out west somewhere.
Oh, sorry.
So yeah, it's all right. So here's some nice photos of great horned owls. The one on the left is showing a bird in flight. The middle showing a foot underneath. We see the talons, and we see the what looks like sandpaper skin, very rough skin. So that's an adaptation for them to be able to hold on to their quarry when they grab it. So they've got their nails in the quarry, and the pads of the feet are very, very rough. So it's hard to get away, especially if they catch some kind of an amphibian, a slippery thing, or a fishing owl with a fish. But this is the great horned owl. And on the right, these are these powerful looking legs and feet of a great horned owl. Look at it. It almost looks like a little bear or something.
That's true. That's true.
So. Now that's a great mount of a great horned owl, isn't it, Uko? Isn't that pretty?
Definitely. Who did it? I mean, it's very nice.
I don't know. Whoever that was a really great taxidermist.
Yeah, definitely.
Yeah.
Yeah.
Well, the only thing about it is that it's not a mounted owl. That's a replica. That's completely artificial, and this is where
I can't believe it, Peter. Yeah, you are joking.
Yeah. No, I'm not joking. That there's nothing real, organic on that owl. No feathers, no bones. It's not a real owl. It's a model of an owl, and there's some more pictures of it.
My goodness.
There's the face and the eyes.
I mean, it's looked like the completely stuffed bird and
It's like a
preparing
beautiful
for taxidermy.
mounted owl. Yeah, look at the bottom of
And it's
the
for the exhibition.
yeah,
Yeah, look at this.
yeah.
Wow. I think
So
we finished the presentation and it's time to have our special guest here.
yeah, we want to know more about this owl. We want to know about who made that, how they made it, and why it's important in some
But
respects to be able to do
move
these.
further, I have a one question. So the all these all species, I mean, right now under threat. I mean, the biodiversity in crisis. So the all species, kind of raptor species, the other raptor species, they are under threat. So what is the main threat in the fields that affect them in the population size and other things and all these species, some of them endangered, some of them vulnerable, some of them near threatened. So
Well,
as far as
obviously,
I
well,
know, the habitat destruction.
right, right. Habitat destruction. I think one of the things that affects owls is poisoning varmints. We put out poison for mice and rats and these sorts of things, and owls will capture these animals that are easy to catch because they're sick and they're dying. And
Right,
then the owl gets poisoned. That's an issue in some places. Of course, with the variation in all these owl species, there's going to be different issues for different ones.
right.
But in addition to habitat loss, poisoning their food is an issue. People don't really hunt owls. I suppose some are killed by poachers and folks like that. And some are just low in number naturally. Some of the island birds and these sorts of things. So um, they basically face the same sort of issues that most of the bird species are.
That's true. Okay. So do you think we should just invite our guest here?
Yeah,
It's gonna be
yeah,
a surprise. I'm gonna take him to the studio. You are ready?
yeah. We're ready.
Hello, George.
Hi, George.
Hello, gentlemen. How are you today?
George,
We
that
are fine. We're so excited to have you here. Thank you so much to coming here. And
No, thank
so
you for having me.
so our guest is George Dante Jr. George is a world renowned taxidermist and model maker, wildlife model maker, sculptor, painter, artist. He's the founder and director slash president of the Institute for Natural History Arts, located in New Jersey and in upstate New York. And he's also the owner of wildlife preservations
Mhm.
in Woodland Park, New Jersey, a taxidermy studio and model making studio. And George showed me this horned owl one day, and I just thought it was one of his many fantastic mounts. He's really so good that the bird looks like it's alive flying. And then I was floored when I learned that that is a model. It is a fabricated great horned owl. And I'd like George to tell us who made it, how they made it, all these neat things about those models. Um, so the floor is yours, George.
So, model making has been around a long time with the use of artificial animals for museum exhibits, and it still continues today, and maybe used today more than ever before, as we try to replicate animals that are extinct or endangered, that we can't get specimens for, and also as we start to use less taxidermy in exhibits because of permits and laws and logistics of traveling and continued care. Models are becoming very, very popular. So the problem we always found is with models, they always look very artificial. And I think with a lot of studios, the quest to make the most realistic bird or mammal is always gonna be a challenge. And with birds especially, you see wood carvers that make unbelievably realistic birds, but there's a tremendous amount of time and effort that goes into that. Most museums, don't have the budgets for something like this. So, we're looking for ways to do this more convincing, more economical. But very simply put, most of the models you see of birds are disappointing. They look plastic. They look very fake because it's very hard to replicate a feather. So, like everyone else, we've been searching, and we do a lot of sculpture, traditional sculpture, meaning we reference the birds. You guys help us out. We take measurements off of study skins, things like that, use live reference, and then basically do a clay sculpture of the bird, then mold it and cast it in resin or fiberglass, something like that, and then paint it. The problem is, again, it looks very fake. You lose the loft in feathers. Certain birds, like raptors, for example, birds of prey, have these very wispy, soft feathers that have a lot of loft in them. They're kind of, for lack of a better term, they sometimes look disheveled. You can see the textures very clearly. So we were doing some research on this one day and came across the studio in Spain, Ricardo and Guillermo Gruber. They're two brothers that are model makers, artists in Spain, and we were looking at some of the bird work they were doing, and we're just absolutely floored. So we have been pushing the envelope here in our studio with, when we had a bird that had some areas on the body that the feathers needed to have more loft in them, we would start to sculpt some feathers and plug them in one by one. Well, at Gruber and Gruber, these gentlemen took it to a whole new level. So that bird is basically comprised of every feather being hand cut out of sheets of polyester and then hand painted and then assembled. And what that does is give you this incredible illusion of this bird being real. You get the loft in the feathers. You get the wispiness of the feathers. It looks absolutely incredible at a close distance. Traditional models, sometimes they're fine when a museum hangs them from the ceiling and they're very high up and, you're only looking at the underside. But when you're dealing with an exhibit where you're very close to it, it's really hard to convince the visitor that this is a real bird. And these models absolutely floor people when they see them.
Yeah, I saw the bird in person, and I remember getting right up to it, and it still looks real. It's
incredible.
It's incredible, and feathers notwithstanding, the soles of the feet, the pads on the feet, and the hair-like feathers on the legs. It's not just one kind of feather that these guys have mastered, right? And
No.
And I know
Subject.
Yeah, and they and you had a snowy owl from them at one point too, right?
Yes.
Yeah, which I also thought was a mount you were working on.
It's incredible. We are so fortunate to have partnered with Gruber and Gruber. We were able to basically become their distributor for the U.S. and Canada because we love their work, and we work with them. We help them, support them with whatever reference they need and things like that. And we used to even send them some partial casts and things. But what's important to understand is the talent that goes into this, because you can take this same process and basically teach 100 different people. They're going to look like 100 different birds. It's the mastery here that goes into this is just bar none. And, I can't say enough about their talents. It's not only the process, but the talent that these gentlemen have.
Now, do they do taxidermy as well, or are they just models?
They do not. It's just models.
That's incredible. And
it is.
Yeah, I imagine a model like that, which is right on in terms of not just the shape and the color and all that, but the size. I mean, they do their research. I imagine those are not cheap.
No, but you know what we found is that they're not that much more expensive than doing traditional sculpted models.
I see.
I mean, traditional sculpted models, if you take like a bald eagle, for example, I don't know what the price would be right now because our cost of materials has been going up literally almost every day. But you're going to be 10 to 15,000 for probably a model of an eagle, and that's sculpted using the old traditional methods. These aren't going to be that much more expensive. It's just because the process is a little different, so you save a little time in some areas and gain in others, but it's really such a night and day difference. And if you think about why do we need to use these models, and I'm a big advocate for taxidermy. I think we should still be continuing the use of taxidermy in a lot of these exhibits, but with the with the issues of pest infestation today, you can't beat the fact that this bird is 100% synthetic, because some of the most realistic bird models that people have created have been using the feathers of domestic birds. So it's very popular to make eagles and things like that using chicken feathers, goose feathers, and things like that. Legally obtained specimens that you can cut the feathers, color them, and put together. The problem with that is when you cut and alter a feather, it's still not 100% convincing. It looks good, but it's not perfect. But you still have the issue with pest infestations. Cloth moths, are an epidemic, and they are still going to attack these. When you can create something like this that's 100% synthetic, you really can't go wrong. Now, from the museum standpoint, from the business end, with traveling exhibits, even if you're using domestic specimens, you're still going to have to do the paperwork for importation, export. With this, there's nothing. It's completely synthetic.
Yeah, I also recall that I have pictures of you assembling this thing. It comes in parts, and then you put it together, and you have this perfectly formed great horned owl that looks not just like a good mount, but looks alive.
It's amazing. Being able to engineer these so they can ship and travel is very important. And again, Ricardo and Guillermo have done an amazing job with being able to make these break down so that they can be easily assembled back together, so we can basically ship them worldwide.
Yeah, that's incredible. And I looked at their website at one point, and Dr. Perktosh is going to link their website to this podcast, as well as the Institute for Natural History Arts and your studio in New Jersey, your taxidermy studio information, so that people can look at your work as well, George. Do you think that these kinds of models will eventually replace mounts?
As much as I love working with these models, I hope they don't. And here's why. I'm a huge fan of these type of models. I love making them. But let's look at it from this point of view. If I were to bring my daughters into a museum and want to show them what a great horned owl looks like, I want them to see a great horned owl. Yeah. I don't want them to see an artist's interpretation of an owl, because you even mentioned this. We were talking about this not too long ago. We said you can create this as realistic as you want, but it's still not an owl. So, I think they have a wonderful place in museum exhibits, but I don't think we should be too quick to stop using taxidermy. I think it's important to show people real specimens, and it's been proven that people want that. They want to come to the museum to see something real.
Yeah, and I think we talked also about, let's say there was a specific exhibit in a museum, and you wanted to do a scene from Alaska, the southern part of Alaska. And we mentioned that there's different subspecies or geographic forms of the great horned owl, right?
Mhm.
So if you were going to do that kind of display and you were going to use models, you would want to make sure that you were making a model of the subspecies or the form that occurs up
Yes,
in that area. So you would need specimen material anyway.
absolutely.
And so, but I think, and Utku might want to say something about this. Utku, this is really kind of a great thing for extinct or near extinct, uh, let's say birds, but other animals as well. I mean, this is great because you're not going to be able to collect those kinds of specimens. They'd have to be manufactured. Um, Zoos may have them, but since they're uncommon and rare, even in a zoo, you can't get these. So this seems to be a perfect way to educate people about endangered or extinct forms without having to go anywhere into the wild or anything like that.
I agree with you. I was going to ask the same question to George because I'm just thinking these kind of models might change the natural history culture in this age. So it's kind of not a traditional way. But I completely agree with George also because when you go to museum, people wants to go to museum and they need to see the, I mean, real specimen. So it is important because natural history has two components, and I think the natural and history just connect together, and because of these real examples and all these models probably gonna get more artificial stuff to the natural history concept, and it might change the culture of the natural history that we already know. So yeah, I was gonna ask the same kind of question, but I just changed the topic a little bit. I don't know, George, what you think? So the culture might change with these things, but it is the Peter's point is also important. We have very important biodiversity crisis in this age, and all these species getting really vulnerable and extinct and endangered situation very fast than the Earth history. So it might help to educate the people, but also to change the culture. What is
I
the? I
think
mean,
we
is there any balance?
I think we have to be very careful how we move forward. I think that's an excellent point. I think it is the culture is changing, and it's almost like when an artist discovers a new tool for the first time, all of a sudden that's all they want to use. But it's not. You have to be able to look at this from the standpoint of, yes, let's use this new technology, let's use these for the good and what they can do for us, but let's not forget that we have to show people the actual specimens. People want to see the real thing, and in building these, you still need to reference specimens. I think it's great if you wanted to build, for example, this very dynamic exhibit that's not behind glass and it's going to be exposed to the elements and it's going to travel. This is perfect to put something like that. And then if you're able to use an actual specimen to show them, it goes inside a very glass case, very protected, climate controlled. These, you have to look at it from the standpoint of the design, what it's being used for. But we have to stay on track and not get away from using actual specimens because, that could just be disastrous down the road. And again, because you're looking at an artist's interpretation. Just because a museum hired an artist to do the piece doesn't mean it's 100% accurate. Because did he consult with a curator? How much research did he do? Is this very accurate? Today, we have to be very careful because sometimes the curators don't get involved with the art process in these exhibits, and that winds up being disastrous sometimes.
Yeah, I think the scientists and people who spent their lives, their careers
Mhm.
in studying a certain species or group of species is a real asset to the artist. I remember years ago, you developed a model of a dodo bird
Mhm.
for
Mhm.
for display, and we still have one of them here that you gave us. And see, that's a situation.
Yeah.
Yeah, that's the situation. The bird is gone, and there were very little references for you, I assume. There are no complete mounts or skins or skeletons.
No.
So piece by piece, I guess you were able to put that together. I don't know if you consulted anyone on that. How did that?
Yeah, that is a perfect example of what we're talking about.
Mhm.
So look at all the dodos that have been recreated, and recreation dodos go way back to Roland Ward, and you
Well,
know,
and paintings from the 1500s.
absolutely,
Yeah.
absolutely, and look at all these artists' interpretations of these birds, and scientific research then found that none of these actually looked like the bird actually did. So everything was just that, this interpretation, and they were wrong. So our dodo at that time was deemed the most accurate dodo in the world because of the scientists we worked with. So as we sculpted that bird, we had, I think there was 3 or 4 of the top dodo experts. I mean, I remember Anwar Janou.
Who's from Mauritius, where the dodo was
Yeah.
endemic. Yeah.
There were several people weighed in on that project, and every step of the way, they would give us information like the stance should be a little bit different, the neck should be a little bit heavier, the feather texture should look like this. That is what's absolutely critical in creating a good model. And it is natural history art is the marriage of art and science. And if we forget that, it's going to be a disaster. We need to make sure we keep this on track with the artists working hand in hand with the scientists.
No, it's all good points. And unfortunately, some of these things are probably going to disappear in our lifetime still. And there may be quite a need to make some reproductions to educate people about what they were like.
Absolutely. And because of that, and it's a very sad reality, because of that, that's also a reason why we have to keep the art of taxidermy alive, because we need to create these archival records of these specimens. And how do we do that? And that is through taxidermy. Taxidermy is a wonderful art form for recording these species. Someday, and again, you can go back to the dodo. It's a great example. There was, I don't know the complete story. There was a dodo specimen at one time at Oxford, but now that all that remains is the foot and the head.
Yeah.
Imagine if a taxidermist had mounted a couple of these birds. What amazing information we've had.
Right.
At the time there was when we did that project, there was more known of a T-Rex than there was about a dodo, and that was just amazing to me. So imagine if we didn't have taxidermy specimens of thylacines or passenger pigeons or Carolina parakeets,
Right.
where we'd be. So I think the taxidermy, making study skins, preparing wet specimens is something that is absolutely critical.
Yeah. No, I couldn't agree more. I'd like to see somebody do the same sort of thing with the solitaire, which was the dodo cousin on the island of Reunion. I haven't seen a good reproduction of that, so maybe you'll be doing that at some point too, George. Although I don't know that there are any specimens of solitaire. I have no idea.
I don't know.
So, yeah.
And also, Peter, I mean, I was gonna tell all these specimens, I mean, real specimens make connection between nature and human being when we get into the museum.
Oh,
So
sure.
this model is not gonna help to feel that way. I mean, am I right? What
Well,
you
it's
think?
like what George said. I mean, when I was 6 years old and I came into the Museum of Natural History, I saw these beautiful mounts, and
Right.
that's what hooked me with these real taxidermic mounts. I don't know that a model of a moose would have done the same sort of thing, regardless of how well it was done. It was just
Yes.
really cool to know that that was
Yeah.
the actual preserved animal's skin, and of course, with the diorama, the actual background, a real place that the animal would have been in. The rocks were there, the leaves, the everything that's in that diorama as a whole is a real place. And I remember wanting to go to that place uh, when I was a kid. So,
It really invokes an emotion that
mm,
you cannot replace. You could take a fossil and put it in somebody's hand and say, look at this. This is 140 million years old, and they'll be just wow.
yeah,
This is, and they're holding this in their hand, and they're just amazed. Now tell them it's a fake,
mm,
and see what happens.
hmm,
It's very different. Like you said, when you looked at that moose, if it was a sculpture of a moose, it might not have invoked the same emotion.
right.
We really need to be careful about that. We want to connect with people on this very personal level, and the way we do that is by showing them the actual things.
Yeah. Wow. Very cool. So it's really neat to
That's
have this sort of this little addendum to our talk on owls. And yeah, George, that's great. Keep up the good work.
Thank you. Appreciate that.
And stick around.
thank,
Well,
thank you,
Utku and
George.
I are gonna, yeah, Utku and I are gonna close it up. But don't go away. We'll talk to you in a
I
minute.
appreciate it, guys. Thank you so much.
Okay. Thank you for your time.
Thank you so much.
How cool is that, Utku?
So, I mean, amazing. I mean, I'm so excited about this. Really amazing.
You see
But
that
it is
owl?
good
Yeah.
to discuss the natural history and history and the culture, put all together and then discuss with George. It was very nice.
Yeah.
So
Sure.
yeah, also all these kind of models will help uh, to understand the biodiversity stuff in the crisis
Yeah, and with
time.
somebody like George and the folks that make those owl models, again, I looked at their websites. Not just birds, not just owls. They make all kinds of animals that are
Yeah,
it's
yeah.
unbelievable, and it's very important.
And also let's talk about this Dodo model in the department in MNH.
Hmm.
So also it is very nice. It helps to get people excited about Dodo and get some information about Dodo. So it's important.
Yeah.
So
Well, now
yeah,
that there's another model of a dodo here from a long time ago, and it's that really big, weird looking thing like from Alice in Wonderland, and it seems to me that you could actually do a display with that. You could have that one, and you could have George's more accurate model, put them together, and talk about this whole thing to people. It's a little mini display in itself. It's all information. It's all important information about natural history, past and present. Yeah.
I think now we have to really try to understand what natural history is because there are lots of things going on in the out there and they just probably some people try to change all these natural history culture,
Yeah.
so which I don't like.
You don't like it. You don't like it. I don't like it. Yeah, that's cool. So, Uku, we'll make sure that we put the links down below so that our subscribers can take a look at
Yes, no
George's stuff.
problem. So
The
everything,
Institute.
every explanation, every link and institute link and everything in the under the video.
Yeah,
So
great.
yeah, so I think it is kind of very great episode. I like it.
Yeah, well, can't go wrong with owls.
Yes. Yeah. Thank you very much, Peter. And next time we are going to talk about grackles,
Yeah, great.
your
Grackles.
yeah, the your bird, and
My birds.
we.
They're my birds. Yes.
Well, you got your PhD using grackles. I mean, you solved some of the mysteries. We put
Yeah.
some good questions together, so we need to discuss and we need to explain to people together. It's gonna be fun.
Yep. We'll see you next time.
Yes, definitely. And yeah, the grackles, and then we have another surprises coming, the different episodes. Thank you so much.
Alrighty. I'll see you soon.
Yep. Bye bye. Yep. Bye. Okay. Thanks everyone. So we got the end of this episode, and well, the others is coming. please subscribe to the channel and follow us on YouTube, and please follow us Institute for Natural History Arts. So, I mean, I really like this episode, I have to be honest, and see you soon.